The course today is called FOSS 4G, GeoAcademy Introduction to Geospatial Technology. FOSS 4G is free open source software for geospatial. I've been involved with FOSS 4G, the community, for a while now. GeoAcademy is the academic stream of FOSS 4G. GeoAcademy is a bunch of academics, university people around the world that is working towards promoting open source for geospatial. So the GeoAcademy people have actually created a university course on geospatial technology. So it contains labs and lectures. And we're doing part one because to do the entire course will take 4 weeks. So we're going to try and do part one. I think the objective we have is to start you going on this, and hopefully in terms of the Canadian projects, we will follow up in the future with part 2 and part 3. And the first component is called spatial analysis. Under there we'll look at the lecture slides and then the lab work, and then following that is data acquisition and management. Every one of these we'll do the slides and then lab work if possible. So then we'll do with cartographic design and then introduction to remote sensing. So we'll use multi-spec because the course actually uses GRASS. The actual academic course uses QGIS and GRASS, and that is much more complicated. So we probably won't get to that on this training. So we may get to multi-spec. Some of you already seen this. Basically what is happening is that you can see that over time, the technology is accelerating, right? So we're really now at the stage where we're up at this end of the curve. So it's very important for us to keep up with the technology, especially in spatial side, in our case. So in terms of information and data, I think this is Eric Schmidt, he's chairman of Google. In a conference last year, he said that every 2 days we create as much information as he did from the beginning of time until 2003. And so this is like 5 exabytes of data every 2 days is information is generated. Now the disadvantage in Mongolia is most of this is in English. So part of our objective here is that we are trying to actually convert some of our data and training into Mongolian, and we're trying to put it on a knowledge portal so that you can have access to it even if you're not comfortable with English. Okay, and this is a slide that I normally use. If we keep the same old thinking and the same old methods, we would end up with the same results. So if you want to improve the results and you want to come up with better solutions to your stakeholders, then you have to change the way you think. Okay, and this is another philosophical one that I use. In the future, I don't want you to tell the other person, I was a good camel and I never made the effort to be a great camel. This is the curriculum. So we're following the FOSS 4G GeoAcademy curriculum. The FOSS 4G GeoAcademy curriculum comprises of 35 university level lectures and labs. Okay, so the lectures focus on what they call vendor agnostic theories and principles. Okay, it means that if you do GIS training, very often the GIS training is biased towards, for example, ArcGIS, which is a vendor. Esri wants to sell their products, so they would develop the training around ArcGIS. So it means that in order for you to learn GIS, you have to buy the Arc product from Esri. All right? So that's a vendor biased theory. Okay? Okay, it means that the course is developed on the theory without any intention of using any specific product. So now the labs focus on the use of QGIS, GRASS, and Inkscape. And the labs are free for you to use and distribute. Okay? Basically, the course is aligned towards the geospatial technology competency model. In terms of the Geospatial Academy, if you go into their website, they also have a book that they've published called Mastering QGIS. Okay? And basically the curriculum, the FOSS 4G Academy curriculum, comprises of 5 modules. So each module, for example, the first module is Introduction to Geospatial Technology. And the 5 modules, these are all the labs. Each module has labs that you can work through. And essentially, starting the introduction would be, if you went to their website then, each lecture is a slide on the website, and you can then scroll through the slides. And these are, we've captured some of these for the presentation. For example, as we proceed then, what are geographic information systems? GIS is a computer-based system that collects, maintains, stores, and allows you to do analysis and output. So I'm going to go quite quickly through this, and I will show you the links later on, and you can go back and walk through it slowly if you like. But for this course, we'll just step through fairly quickly, so you'll get an example. Okay, for example, collection. Then collection refers to the ability of GIS to ingest many different types of information, different formats, different types of data. So maintenance refers to the ability to keep the collected data up to date, so it can deal with static and dynamic data. Storage is the coding of the information stored in digital format on the computer. And analysis, it allows you to do spatial analysis, and we'll see examples of that later on. And outputs, you generate maps, reports, and statistics. GIS, you can consider it like an umbrella that covers hardware, methods, software, data, and network, and people. So, components of a GIS. So these are the different components. Hardware, like your laptop. Software would be QGIS, Inkscape, etc. Data, GIS data is all kinds of data, like shapefiles, maps, raster images. And then methods, it's formulas, statistics, analysis, and algorithms. You have different kinds of people: skilled GIS professional, skilled GIS users, novice GIS users, and public users. Yeah. So in our case, we kind of fit into this group. Okay, a network is both the computer and the social network. So we talk about dissemination of data, transfer of data sets, collaboration, okay, display information, web mapping, web applications. And how can GIS be used? So examples of GIS use: cadastral information, deliveries, military, farming, wildlife mapping, disaster management, infrastructure, decision support, 3D analysis, mapping, redistricting, health, data mining, and natural resources. Spatial analysis. The concept of spatial analysis is space, location, and distance. So the idea of topological space, this is relative space. Absolute space, an example of absolute space is latitude and longitude. Okay, your coordinate is an absolute space. And relative is site and situation, okay, where your place is. Cognitive is a name. Nominal is where were you when. Absolute space, an example of absolute space is latitude and longitude. Okay, your coordinate is an absolute space. And relative is site and situation, okay, where your place is. Cognitive is a name. Nominal is where were you when. Absolute location is typically expressed as a coordinate. This is not that important. Site is like physical attributes, the terrain, the soil, the vegetation. The building environment is the site. First law of geography. Everything is related to everything else, but near things are more related to each other. So obviously more near is better. Now, so these are links. This is a link that I have in the slides. When you have the slides, you can go to the link. So the link is FOSS4G-Academy-curriculum. Okay, so this is the Geo Academy, all right? You can go, any one of you can later on go to these academies. So we can say introduction, which is what we just looked at. So, all right, so these are the labs. So for example, geographic information systems, this is what we just looked at. You can just click on it. Okay, so for example, do I want to resume where I left off? So you can all go to it and you can say yes or no. I can say no. Basically, you just step through it. So I have captured it in slides in case some of you may have difficulty with the internet. Okay, so the PowerPoint has all these. Now, all this information is part of the Geospatial Academy. Go to home page. We showed you the home page earlier. So 101. So what we're going to do as part of our 3-day course, mainly we're going to run through the introduction, which is the 101, okay, with the labs.